Hello everyone, this is part 1 on how to make a racing game in Scratch. In this tutorial, I will be creating a large scrolling racetrack map and a race car with smooth controls. Anyways, let's get started. So the first thing I'm going to do is create the race car sprite and the racetrack sprite. So anyways, I will do that and I will be back shortly. Alright, so I am done. For my car, I just quickly drew one like this. And for my racetrack, I just used the paint tool, or actually the brush tool, and then I just drew a quick track around the drawing area. And also, I added a green background for my stage, so it looks like the grass. But yeah, anyways, now I'm going to first do some coding on the track. So I wanted to make the track really large and scrollable. So to do that, we could just go to looks and then set size to a really large size, for example, 999%. However, this doesn't really work because the track is still pretty small. And that's because Scratch has a size limit on sprites, and since our sprite is pretty large in terms of size, we can't make it any larger. So this is the maximum size it can go to. However, to not run into this problem, we could go to costumes and then create a new costume, and we can just use our brush tool and paint a dot in the center. And that's all we need. So let's go back to the code. And what we can do is first grab a when flag clicked. Then we can switch the costume to the dot costume. And then we can set our size to a really large number. I'll say maybe 600% in this case. And then after that, we can switch our costume back to costume 1, which was our original racetrack costume. So since our dot is really small in terms of size, the dot can be made really large, but then right after that, we switch our costume to the racetrack costume. And this way we have our really large racetrack without the size restriction. Anyways, let's try it out. So as you can see, our racetrack is very, very large. So I'm going to make it go to 0, 0. And that should be fine. So the next thing I want to do is to make the car sprite smaller. So maybe I might set the size to 30%. Okay, maybe 40%, I guess. Alright, that looks fine. So let's put that under a when flag clicked. And also grab a go to front. This way the car is in front of the racetrack. And let's also go to motion and then grab a point in direction 0, I think. Yeah, 0. And this way the car is facing up. And now that should be fine. Oh yeah, I also want to add a 0, 0 to make the car in the center. And of course, I want to move the racetrack so that it's in the middle of the car. So that would be X position -101 and Y position 16. Alright, I might move this to the right a bit, so maybe -90. Okay, that looks fine. But anyways, now we have our basic car and racetrack. So now we want the car to be able to move. But we also want realistic movement. So we want the car to accelerate and decelerate and maybe do some turning and stuff like that. So to do that, let's start with a forever loop. And we want to check if the up arrow key is pressed. Then let's say we make the car move forward. So to do that, we could go to motion and then drag a, move 10 steps or change Y by 10. However, we want the car to accelerate. And if we just do a move 10 steps, then the car moves forward by a constant amount. And we don't want that. We want the car to actually accelerate or move faster over time. So to do that, we have to create a variable. And I will call this Y velocity, or YVEL for short. And that's essentially the speed of the car's Y position. So if our Y velocity is 1, that means our car is moving forward 1 step. And if our Y velocity is 0, that means our car isn't currently moving. So now we want to check if our up arrow key is pressed. then we want to change our y velocity by, let's say, 0.5. And this is going to be our speed. So as we hold our up arrow key, this y velocity is going to increase. So as you can see right here, if we hold the up arrow key, then our y velocity increases. Of course, by a lot, but we can fix that later. But now we want the same thing, except opposite, when our down arrow key is pressed. So we can just right click, duplicate it, and then change this to if key down arrow is pressed, then change y velocity by negative 0.5. And this way the speed of the car decreases when you press the down arrow key. And of course right now we don't have any movement. However, I actually don't want the car to move, because if the car is moving, then it would just eventually go off screen. So I actually want the track to move. So we won't actually have any movement blocks in the car sprite. So all the movement is going to be in the track. So to do that, we have to make the track go to a position based on how much the car already moved. So let's create 2 more variables. Let's call this maybe scroll x and scroll y. Alright, so this is going to be essentially our x and y offset. So in our track sprite, we want to constantly make it go to the x position of scroll x and y position of scroll y. So let's grab a forever loop and do that. So I'm just going to put this around this go to xy, or actually not yet. So I'm going to drag a new one, and then I'm going to drag scroll x into the x and scroll y into the y. So essentially, these variables replace the position of the track. And since these variables replace the position of the track, we want to, instead of making the track go to negative 90 and 16, we want to actually set the variables of scroll x to negative 90, which is the beginning x position of the track, and also set scroll y to 16, which is the beginning y position of the track. Alright, and then we don't need this anymore. And now we can drag the forever loop under all of this. Alright, and right now this still does nothing. And that's because we haven't done anything to the scroll x or scroll y yet. So let's go to our race car. And we want to make it so that whenever the race car moves, we change the scroll x and scroll y based on the change in the x speed and the y speed of the car. So let's drag a change scroll x by our x velocity, which we haven't made yet, so I'll just create a new variable and call this x velocity. So change scroll x by x velocity, and also change scroll y by y velocity. And now let's try it out. So of course, I'm going to reset the y velocity to 0 at the beginning, because our y velocity was a huge number. So let's reset that, and now let's try it out. So of course, I haven't done anything to the x velocity yet, so I'm going to be only testing the y velocity. Anyways, if we do it, okay, the car is moving backwards. And that is because, oh yeah, so for our track, we should actually go to the scroll x and scroll y multiplied by negative 1. So let's just do that. Alright. And that is because when the car increases in speed, let's say when it's going forward, the track is actually moving backwards. And that's what makes the car look like it's going forward. That's why we have to multiply by negative 1 in both the x and y position. Anyways, let's try it out. And alright, now that works. So as you can see, it looks like the car is moving forward. Alright, so now the next problem is that the car never stops. Right now, I released the up arrow key, however, the car is still moving forward. And we don't want that, because in real life, the car would gradually slow down. So to fix that, we can actually just go to variables and let's set our x velocity to x velocity times, let's say 0.9, maybe 3 or something. And then do the same for the y velocity. So set our y velocity to y velocity times 0.93. So what this does is that this makes the y velocity and y velocity decrease over time, which means that if we're not increasing the velocity, then the velocity eventually reaches to 0, and this way the car stops. So let's try it out. Okay, and as you can see, the car stops like that. Alright, cool. So now the next thing I'm going to do is to implement some rotation of the car with the right arrow and the left arrow. So what we can do is to duplicate these two, put this back, and then take out the change y velocities. And now let's change this to if key right arrow is pressed. Then let's just go to motion and turn maybe 5 degrees. And if our key left arrow is pressed, then turn counterclockwise 5 degrees. Alright, let's try it out. And as you can see, we have our rotation. However, as you can also see, the car does not move based on its rotation, and that is because we're simply increasing or decreasing the y position when we press the up arrow or down arrow. So it doesn't care what direction the car is in right now. And to fix that, we actually have to do some trigonometry. So if you don't understand trigonometry or don't know what that is, that's fine. I'll give a quick explanation, but do keep in mind that it is pretty confusing. So if you don't understand it right away, that's fine. But if you do, of course, that's great. So anyways, I'll just create a new sprite, and I'm just going to explain it right here. So let's see. So what we have to do to make the car actually accelerate, given its current direction, is to first find the angle in which the car is currently at, and then change its x and y positions based on that. So I'm going to select or actually change the brush size to a much smaller one. Alright, that seems fine. So let's say our car is positioned this way. So these are the headlights, and it's moving this way, with this arrow being the speed. Alright, let me actually write that better. Sorry. So I'm going to make this a bit smaller. Alright. So with this arrow being the speed of the car. And what we want to do is that we want to change the x position and the y position of the car so that it moves in this direction. So to figure out how much to change the x position and the y position by, we have to first know what angle the car is at. So let's say the car right now is at 40 degrees. So that means this angle here is 40 degrees. Alright, I'll just zoom in a bit. Okay, and if we want to know how much we change the x position by, or this line right here, then we have to know the sine of this angle, which means we have to know the sine of 40 degrees. And the sine is essentially the opposite over the hypotenuse. So the opposite line based on this angle over the hypotenuse, which is the longest side of a triangle. So given this, since we want to find the opposite side over here, which is the change in x position, we also want to multiply this by the hypotenuse, which is the speed. And this way, the hypotenuse essentially cancel out, because just as a reminder, this is the x side over the hypotenuse. So essentially, by multiplying by speed, you get the remaining horizontal side, which is this one. And that's how you find out how much you change the X position by. And for the Y position, it's almost the same thing. So what you do is that you do cosine 40 degrees instead of sine 40 degrees, since cosine is adjacent over hypotenuse. That means that you get the adjacent side of this angle, which is this one, over the hypotenuse, which is this, of course. So that means it would be cosine 40 degrees multiplied by speed again, because you're trying to find the Y side. Oops. Let me go back. Alright. And the cosine is, of course, essentially Y over speed. And now we can use these two equations to plug into our car. So this one and this one. So again, this may be really confusing, but that's essentially what we have to do to find the change in the X speed and Y speed for the car. So now I am going to erase this, alright, and let's go back to the car. So using our equations from before, when we press the up arrow key, we want to change the X velocity by, let's see, let's go here. So X would be sine of the car's direction. So sine of direction multiplied by the car's speed. So times 0.5. And to make this less confusing, I'm actually going to create a new variable, and I'll call this speed. Alright, so I'm going to set speed to 0.5, and then drag my speed variable into here. Alright, so this is what we change our X velocity by. And for our Y velocity, we can just duplicate this. And remember, it was cosine of direction, since adjacent over hypotenuse. So cosine of direction multiplied by speed. Alright, and if we press the down arrow key, then it goes backwards. So it's essentially the same thing, but multiplied by -1. So we can just go to operators, grab a times -1 from our sine of direction, times speed. Oops, okay, that is cosine for our Y velocity, and for our X velocity, that would be sine of direction times -1 times speed. Alright, cool. So now this should work. So let's try it out. Alright, and as you can see, the car works. So if the car is, let's say, right here, then the car is going to be moving in that direction. Alright. So let's keep playtesting. And it's like that. So the car sort of drifts around like this. Alright. And now we have the complete car movement. I might improve it in future videos, but for right now, it's fine. So let's go around the track. Let's see how it looks like. Alright. Okay. Looks pretty good. And of course, right now, the car does not slow down yet when it touches the grass. But yeah. Okay, so everything seems to be working. Alright. Anyways, that's it for this video. If you enjoyed it, then give it a thumbs up and subscribe too, if you haven't already. In the next video, I might make the racetrack and car look better, and make the car slow down when it touches the grass, and more. Anyways, that's it for this video. See ya!